Tonight on Dark Matter Nap, we are going to confront the most terrifying and misunderstood property of our reality. When you step outside on a clear, moonless night and look up at the sky, the universe appears crowded. You see thousands of stars scattered like crushed diamonds across the black canvas. If you look through a telescope, that crowd thickens into millions of glowing suns, vibrant nebulas, and sweeping galactic spirals. Science fiction has trained us to view space as a bustling ocean, filled with planets to explore, empires to build, and destinations to reach. We naturally assume that the universe is a story about matter, a story about the things we can see and touch. But the sky is lying to you. The glowing structures of the cosmos are nothing more than a microscopic illusion, a vanishingly thin layer of foam sitting on top of an unfathomable ocean of absolute nothingness. The defining characteristic of our universe is not stars, not planets, and not life. The defining characteristic of reality is the void. Tonight, we are going to dive into the deep dark. We will zoom all the way down into the invisible architecture of your own body, travel out through the desolate frozen deserts between the galaxies, and uncover the terrifying physical reasons why the cosmos is actively erasing its own structure. Before we look into the abyss of the grand void, take a second to like this video and subscribe to the channel. It helps us reach more curious minds like yours. Now, settle in, turn off the lights, and let's face the emptiness. To truly understand the cosmic void, we cannot start by looking up. We have to start by looking inward at the very building blocks of the matter you consider solid. Look at your hand. Touch the desk in front of you. It feels dense, heavy, and impenetrable. But physics reveals a deeply unsettling truth. You are made almost entirely of empty space. Everything in the universe, from the core of the sun to the cells in your heart, is constructed from atoms. For centuries, scientists believed atoms were solid, indivisible spheres. But in the early 20th century, an experiment by Ernest Rutherford shattered this illusion. By firing radioactive particles at a microscopically thin sheet of gold foil, he discovered that almost all the particles passed straight through without hitting anything at all. An atom is not a solid sphere. It is a vast, empty architectural frame. At the absolute center of the atom sits the nucleus, a dense cluster of protons and neutrons. Orbiting far away from this center is a ghostly cloud of electrons, but the scale is what breaks human intuition. If you were to enlarge the nucleus of a hydrogen atom to the size of a marble and place it on the 50-yard line of a professional football stadium, the single electron orbiting that nucleus would be a tiny speck of dust flying around the highest rows of the grandstands. Everything in between that marble and that speck of dust is absolute, dead vacuum. In pure mathematical terms, an atom is 99.99999% empty space. The solid world you interact with is a physical illusion generated by the electromagnetic repulsion between these ghostly electron clouds. If you could somehow switch off those electromagnetic forces and compress all the actual solid matter inside the human body, an adult human would shrink down to a size smaller than a grain of salt. If you removed all the empty space from the entire human race, all 8 billion people on Earth, the remaining solid mass would easily fit inside a single sugar cube. You are a ghost, walking through a world of ghosts, completely blind to the fact that you are made of nothing. Now that we understand that solid matter is an illusion, let's zoom out and look at the environment where we live. We call it the solar system, implying a cohesive, connected structure. We see diagrams in textbooks where the planets are lined up closely together, brightly colored spheres sitting just a few inches apart. Those diagrams are the greatest lie taught in modern education. Let's start with our closest neighbor, the moon. When you look at the moon, it feels like it's hanging just above the clouds. But the distance separating Earth and the moon is roughly 238,000 miles. That gulf is so vast that you could take every single other planet in the solar system, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, and line them up side by side in the space between Earth and the Moon, and they would all fit with room to spare. And that is just our front porch. If we look toward Mars, our closest planetary neighbor and humanity's great future destination, the emptiness becomes lethal. At its absolute closest approach, Mars is roughly 34 million miles away. To cross that void using our current chemical rockets takes 7 to 9 months of drifting through a lethal, irradiated vacuum. There are no rest stops. There is no breathable air. There is nothing but the hard, cold vacuum of the interplanetary medium. But the true scale of our local void is best understood by looking at the Voyager 1 space probe. Launched in 1977, Voyager 1 is the fastest machine humanity has ever built, screaming away from Earth at over 38,000 miles per hour. It has been flying continuously for nearly half a century. In 2012, it finally crossed the heliopause, leaving the magnetic boundary of our solar system. It feels like Voyager has traveled an eternity, but if we measure the distance to the Oort cloud, the icy shell of debris that marks the true gravitational edge of our sun's influence, Voyager 1 has barely left the driveway. Traveling at 38,000 miles per hour, it will take Voyager another 300 years just to reach the inner edge of the Oort cloud. It will take it 30,000 years to fly through it and finally enter true interstellar space. The solar system is not a bustling planetary neighborhood. It is an agonizingly sparse scattering of dust trapped in a massive sphere of nothingness. If the space between planets is vast, the space between stars is mathematically violent. We live in the Milky Way galaxy, an island of roughly 400 billion stars, but those stars are not clustered closely together. The average distance between stars in our local galactic neighborhood is roughly 4 or 5 light years. Our closest stellar neighbor is a small red dwarf star named Proxima Centauri, located 4.24 light-years away. Light, the fastest thing in the universe, takes over 4 years to cross that gap. If you were to board Voyager 1 today, traveling at its blistering speed, it would take you over 73,000 years to reach Proxima Centauri. To visualize this emptiness, imagine shrinking the sun down to the size of a standard basketball. If you place that basketball in the center of New York City, the closest star, Proxima Centauri, would be another, slightly smaller basketball sitting somewhere in South America. Between New York and South America, there is absolutely nothing. No planets, no light, no warmth. Just a freezing, unyielding vacuum holding a temperature of -454 degrees Fahrenheit. This means that the beautiful, sweeping spiral arms of the Milky Way you see in telescope photographs are a trick of the light. The spiral arms look like dense, solid walls of stars packed tightly together like traffic on a crowded highway. But astrophysics reveals that they are completely porous. The distance between individual stars is so immense that they almost never physically touch. To prove this, we can look at the future of our own galaxy. In roughly 4 billion years, the Milky Way will collide with the Andromeda Galaxy. Two massive islands, containing hundreds of billions of stars, will violently smash into each other at hundreds of thousands of miles per hour. But because the space between the stars is so vast, astrophysicists calculate that during this entire multi-million-year collision, the probability of any two stars physically striking each other is practically zero. The two galaxies will simply slide through each other like two clouds of smoke. The collision is a dance of gravity, not a clash of solid matter. Let us pull back even further, leaving the Milky Way entirely, and enter the true master of the cosmos, the intergalactic medium. If you thought the space between stars was empty, the space between galaxies redefines the concept of a vacuum. In the interstellar space inside our galaxy, the density of matter sits at roughly 1 atom of hydrogen per cubic centimeter. It's sparse, but there is a physical texture to it. When you enter the vast intergalactic chasm separating the Milky Way from Andromeda, the density drops to a level that borders on absolute, pristine nothingness. In the deep voids between galaxies, the density of matter averages out to roughly one single atom per cubic meter. That is an absolute vacuum, far more pure and complete than anything human engineers can produce inside our most advanced scientific laboratories on Earth. If you stood in the middle of intergalactic space, you would be standing in a room of absolute vacancy, where a single subatomic particle might pass your coordinates only once every few hours. There is no matter to touch, no radiation to warm you, just an infinite desert of space-time fabric running its expansion loops in total silence. Despite this extreme sparseness, the galaxies that do exist are organized into the largest physical structure in the universe, the cosmic web. When we map the positions of millions of galaxies across billions of light years, a complex architectural pattern reveals itself. The universe looks precisely like a glowing biological neural network or a massive, cosmic sponge. This web consists of massive, glowing filaments made of hydrogen gas and dark matter that stretch across the observable horizon. Galaxies are threaded along these filaments like glowing beads on a string. Where multiple filaments intersect, gravity pulls matter together into dense hubs called galaxy clusters. But between these magnificent filaments of light sits the true owner of cosmic volume, the immense, unyielding deserts known as the cosmic voids. Cosmic voids are regions of space where almost no galaxies exist. They are not minor gaps. They are colossal expanses that dominate the entire layout of the cosmos. Observational data reveals that these voids occupy roughly 80% of the entire volume of the universe. All the filaments, the clusters, the stars, the planets, and every piece of biology in existence is squeezed into a minor 20% fraction of space. The most terrifying of these empty spaces is the Boötes void. Discovered in 1981, the Boötes void spans close to 330 million light-years in diameter. To put that into perspective, a typical region of space that size should contain roughly 10,000 galaxies. When astronomers mapped the Boötes void, they found fewer than 60. If you took the Milky Way galaxy and placed it at the absolute center of the Boötes void, the human race would not have known that other galaxies existed until the invention of deep space telescopes in the 1960s. For all of human history, astronomers would have looked out into the night sky, mapped the stars of our own galaxy, and then seen a pitch-black, dead horizon in every direction. They would have assumed that the Milky Way was the entire universe. The Boötes void is a physical manifestation of isolation, a sphere of nothingness so vast that light itself takes 300 million years just to cross it. But why is the universe built like this? Why didn't matter spread out evenly? Why is 80% of the cosmos a dead zone? To answer this, we have to look back to the very beginning of chronology, the first fraction of a second after the Big Bang. In the beginning, the universe was an incredibly hot, dense point of energy, but it was not perfectly smooth. At the subatomic level, the universe was governed by quantum mechanics. Quantum fields are never completely still. They boil and bubble with quantum fluctuations, random, temporary spikes and dips in energy. During an event known as cosmic inflation, the universe expanded at an incomprehensible speed, stretching from the size of a subatomic particle to macroscopic scales in a trillionth of a second. When this happened, those microscopic quantum fluctuations were instantly frozen and stretched across the fabric of space-time. These stretched fluctuations created tiny variations in the density of matter. Some regions of the early universe had a microscopic fraction more hydrogen gas than others, and some regions had slightly less. Over hundreds of millions of years, gravity went to work. The regions with slightly more matter exerted a stronger gravitational pull, dragging in gas from their surroundings. The regions with slightly less matter began to lose what little they had. The rich got richer, and the poor got poorer. Gravity systematically hollowed out the empty regions, sweeping the matter into the glowing filaments of the cosmic web we see today. The cosmic voids were not created by an explosion pushing things apart. They are the result of gravity hoarding the limited supply of matter into tiny, isolated islands. The emptiness was there first. Galaxies are simply the small points where gravity managed to win a temporary, localized war against the void. But gravity is not the only force shaping the deep dark. Behind the visible stars and the glowing gas, there is an invisible scaffolding holding the fragile web together. We call it dark matter. When astronomers calculate the gravitational mass required to hold galaxies and clusters together, they realize that the visible matter, the stars and the planets, is not nearly enough. Without a massive amount of extra gravity, galaxies would literally spin themselves apart, slinging their stars into the intergalactic void like loose water from a wet tire. Dark matter makes up roughly 27% of the mass energy of the universe, while the visible matter we see makes up less than 5%. Dark matter does not emit light, reflect light, or interact with electromagnetism. It is a completely invisible ghost, but it has mass, and it provides the gravitational anchor that prevents the visible universe from dissolving. The sparse, scattered islands of light we call galaxies only exist because an invisible ocean of heavy ghosts is holding them in place. We are a minor, decorative garnish sitting on top of an architecture we cannot even see. If the story ended there, the emptiness of the universe would be a static, unchanging fact. But in 1998, astronomers discovered that the void is not peaceful. The void is actively aggressive. By measuring the light from distant supernovas, two independent teams of scientists realized that the expansion of the universe wasn't slowing down under the pull of gravity. It was accelerating. A mysterious, repulsive force built directly into the vacuum of space was pushing the galaxies apart. We call this force dark energy. Dark energy makes up roughly 68% of the universe. It is the dominant force of reality, and its behavior is completely hostile to the existence of structure. Dark energy doesn't just push galaxies through space, it creates new space between them. And because space is expanding everywhere uniformly, the cumulative speed of expansion increases with distance. The farther away a galaxy is, the faster it is receding. At a certain distance, the speed of expansion exceeds the speed of light. This creates the cosmic event horizon. Any galaxy sitting beyond this horizon is permanently, physically unreachable. Even if humanity built a starship that traveled at the speed of light, we could fly for eternity and never reach them, because the space between us is growing faster than our ship could ever travel. The horrifying truth about dark energy is that it is increasing the emptiness of the universe every single second. Right now, thousands of galaxies are crossing the cosmic event horizon, their light stretching out into invisible radio waves as they fade from the observable universe. The cosmos is actively systematically isolating its local structures. Billions of years from now, dark energy will have pushed every single galaxy outside of our local group past the horizon. The cosmic web will be torn apart. The highways of the universe will close permanently. Future astronomers living in our solar system will look up with their most advanced telescopes and see a completely pitch-black sky. They will have no evidence that other galaxies ever existed. The universe is heavily invested in erasing its own history, and dark energy is the eraser. This brings us to the ultimate, chilling endpoint of the cosmic timeline. Physics dictates that the universe is governed by entropy, the inevitable progression from order to disorder. Because the cosmos is expanding, it is slowly cooling down. The era of stars, the warm, light-filled epoch we are currently enjoying, is just a brief, temporary spark at the very beginning of eternity. 100 trillion years from now, the last red dwarf stars will exhaust their hydrogen fuel. They will quietly fade into black dwarfs, cold and dead. The universe will enter the degenerate era, populated only by frozen planetary corpses, neutron stars, and black holes. But even these dense remnants are not safe from the emptiness. According to quantum mechanics, even protons, the building blocks of atoms, may eventually decay into lighter subatomic particles, dissolving the very fabric of solid matter. The dead planets and extinguished stars will slowly evaporate into thin wisps of radiation. In the final, darkest epoch, the black hole era, the only structures left in reality will be supermassive black holes. But Stephen Hawking proved that even black holes are not eternal. Over unfathomable timescales stretching to a googol of years, a one followed by 100 zeros, black holes slowly leak mass through a process called Hawking radiation. One by one, the final titans of gravity will evaporate, vanishing in sudden, silent flashes of gamma rays. When the last black hole dies, the universe will enter the heat death. The temperature of the cosmos will drop to absolute zero. All matter will be gone. All energy will be evenly distributed and completely useless. Time itself will lose its meaning because there will be no events, no motion, and no observers to measure its passage. The universe was born from the void, and after a brief, violent, beautiful flash of complexity, the void will reclaim it permanently. Emptiness is the true, natural resting state of existence. This realization triggers a deep, existential vertigo. We look at the vast, cold, empty deserts of space, the unbridgeable gulfs between stars, and the terrifying acceleration of dark energy, and we feel insignificant. We ask why the universe is so hostile, so vast, and so empty. But there is a final, philosophical paradox hidden inside this emptiness. It is known in astrophysics as the anthropic principle. If the universe was not mostly empty, you could not exist to ask the question. If the density of matter in the universe were just a tiny fraction higher, the collective gravity of all that mass would have overwhelmed the expansion of the Big Bang. The universe would have collapsed back in on itself in a violent big crunch billions of years ago, crushing any possibility of life. If the stars were placed closer together, the night sky would be blindingly bright, but the gravitational chaos would make stable planetary orbits impossible. Planets would be constantly flung into the freezing dark or sent crashing into their host stars. The lethal radiation from nearby supernovas would constantly sterilize any biosphere attempting to take root. If atoms were not mostly empty space, the nuclear reactions that power the sun would run too hot and too fast, burning out in a few million years, rather than the billions of years required for biological evolution to craft a conscious mind. The emptiness is not a mistake. The emptiness is not a prison. The vast, silent voids of space are the exact architectural shock absorbers required to keep the chaotic, violent forces of gravity, radiation, and nuclear fusion from destroying the delicate chemistry of life. We require the silence to hear ourselves think. We require the cold vacuum to dissipate the waste heat of our suns. The void is the cradle that protects the spark. Thank you for joining me tonight on this massive, immersive exploration into the architecture of the void here on Dark Matter Nap. If this long journey through the empty spaces of atoms, the Boötes void, and the terrifying mechanics of dark energy challenged your perspective on reality, please take a moment to like this video and subscribe to the channel. Your support is the exact engine that gives me the capability to continue creating these late-night, deep dives into the absolute mysteries of our existence. The next time you walk outside on a dark night and look up at the stars, do not feel crushed by the vast, silent spaces between them. Do not view the emptiness as a hostile barrier. Look at the deep dark with a quiet reverence, knowing that the nothingness is the exact, perfect shield that allows your temporary, beautiful biology to exist in a universe of fire. Sleep well tonight, knowing that the void is holding you safely in the dark. Good night, and may your dreams span the infinite gaps of the cosmos.